Okay, just to finish up the rest of chapter 1. So we know that units are a big deal and incredibly important in chemistry. You should never have a number without a unit because that unit tells us what we're actually looking at. But aside from that, sometimes you're going to encounter units that are raised to a power. So say, for example, you need to go from, cubic millimeters to, square feet, whatever it is. What you have to do is you have to raise both the number and the unit itself by the power. So you can see the example there. Finally, the last thing that we need to talk about is order of magnitude estimations. Calculation, we know, is the central core part of chemistry. It's a lot of what we do. We have to come up with ways to make estimations because a lot of the measurements and data we work with are, either not needed to have a very accurate number, or we're just not capable of getting a more accurate result. It's kind of like, how do we calculate all of the stars in the sky, how many there are? So what we use is order of magnitude estimations, and we focus strictly on the exponential part of the number. We're left with powers of 10. They're very, very easy to work with. They're not accurate, but very easy to work with. So the two main guidelines are if the decimal part of the number is less than 5, we're going to let it go. So if it was 3.54 times 10 to the 3, it's 10 to the 3 because the decimal part of the number is less than 5. If it is greater than 5, we're going to round up to 10 and rewrite as a power of 10. So 7.23 times 10 to the 3 becomes 10 times 10 to the 3. Also, I wanted to point out the decimal part being that last digit there is what, so because you may have been confused saying, well, 0.54, but there is a 5, but I'm looking at the 4 there when I make my order of magnitude estimation. I hope all this information has been helpful having it explained to you. I also want to show my references, which is all the information in this came from your class textbook. Thank you.